Good day, everyone. So today we will be discussing additional problems naman, or we will be solving additional problems of differentiation of trigonometric functions, particularly time rates. Supposedly, this is the last topics that we will be conducting yung face-to-face session, but because I have events and meetings yesterday, so I was not able to meet you guys and today also. So I made this video discussion so that we'll still be able to conduct our examination on Monday. So let's start. Let me read the problem. A revolving beacon is situated 3,000 feet off a straight shoreline. The beacon rotates at a constant angular velocity of 5 pi radians per minute. How fast is the beam of the light moving along the shore at the moment it passes the point on the shore nearest to the beacon? Provide the answer in feet per second. So many of you get confused ano ba itsura nun. Okay, so di ba beacon is para yun, di ba, searchlight nandun sa ocean for yung mga boats, yung mga ships. So, we will be solving this one na naka-top view tayo, class. Top view, ha? So, ganito yon. Ito yung top ng beacon. So, nagro-rotate yung searchlight niyan or yung light niyan dyan. Ano yon? 5 pi radians per minute. Yan yung ano niya, no? Rotation niya. And we will call that rotation to be equal to our d theta over dt. Now, yung beacon daw is 3,000 feet. Okay, 3,000 feet of a straight shoreline. So, ito yung shoreline or baybay, no? So, yan yung shoreline, straight yan. So, this is, yung shoreline is 3,000 feet from the beacon or yung beacon is 3,000 feet from the straight shoreline. So, habang nagro-rotate yung beacon na yan, okay? So, di ba yung beam of light, so for example, in this case, ito yung beam of light. Let me just have a different color, no? This is the beam of light, no? So, ito, pag mag-move yan dito, papunta yan dito, dyan. And then, so on and so forth, ganyan, no? So, ang sabi dito, how fast the beam of the light moving along the shore. So, ano yung velocity or speed ng beam of light. So, we'll call this one x. Etong shoreline na to, let's call that x. So, what we are trying to solve here is the dx dt value. Now, sabi din dito, the moment it passes the point on the shore nearest to the beacon. So, ang ibig sabihin nito is that yung nearest point on the shore, yung point nearest to the beacon is actually yung point here. So, at 3,000 feet, yan yung pinaka-shortest possible distance, no, ng beam of light from the beacon. Kasi kapag dito na, mas mataas na yan or mas malayo na yan compared dito. So, at this particular point, kapag nandyan yung beam of light natin, and what we are expecting is that the angle dito na nabuo is actually 0. Tama ba? Kapag yung beam of light is at the nearest point, ito, yung angle niya dito with respect to the same axis is actually 0. Kaya, for this particular problem, at the shortest or nearest point to the beacon, your angle should be equal to 0 degree. So, dapat maintindihan mo yan. Okay? So, what we can do right here is that we will be relating this side x with this 3,000 feet because yung 3,000 feet hindi naman nag-change yan. So the trigonometric function that we can use is obviously tangent. Okay, we get the tangent of theta equivalent to, so your opposite, that is x, over your adjacent, which is 3,000 feet. Now we will directly derive this one with respect to time. So we have here the derivative ng tangent theta, as you all know, secant squared theta d theta over dt. And that is equivalent to yung derivative naman ng x with respect to time, that is 1 over 3,000. Let's set that aside. Then we have here dx over dt. Since your angle at the nearest point is 0 degrees Celsius, therefore this one will be just equal to 0 degrees Celsius. Degrees Celsius. Sorry, this one is 0 degrees. Sorry. So this d theta over dt is what? 5 pi radians per minute yan. So we will divide this one by 60 so that magkaroon tayo ng radians per second. Kasi we need to solve this one or to provide our answer in feet per second. This one is 1 over 3,000. Ito man class is feet, tama ba? 1,000, 1 over 3,000 feet. So, second squared theta is just equal to 0. Kaya, we have here dx over dt. So, dito na lang. So, therefore, we have dx over dt. Cross multiplying, we have equal to 5 pi over 60, and that is times 3,000. No? This is about, if you put this in your calculator, this is about 250 pi. Okay? Region, no, that is feet already. Feet per second. And that is basically your answer for this problem. Okay? So we will try to solve additional problems similar to this one. No? Okay, this one. A searchlight is located on the ground 20 meters from a straight wall. So we have here, top view pa rin tayo class. In problems like this, you can solve this one or visualize this problem using the top view. No? Ito yung light natin, searchlight na nagro-rotate yan. At what that the light rotates at a constant rate, that is d theta over dt, and that is equivalent to 0.1 radians per second. Now, how fast is the beam of the light moving along the wall? So, etong searchlight na natin is ang distance niya from a straight wall is 20 meters. So, ito yung straight wall. Same thing pa rin kanina, yung beam of light nito, ito, ganyan, no? Yan, papunta din dito, ganyan din dyan. Habang nag-rotate yan, no? Then, sabi dito, how fast is your distance x or how fast the beam of light moving along this wall at the moment it is at a distance of 15 meters from the point on the wall closest to the searchlight. Same thing with this problem right here. The closest point to the beacon is at this point. So in the same sense or the same way, and the closest point going to this searchlight is at this point, no? Tapos sabi dito, we are to determine dx over dt when the beam of light is at distance 15 meters from the point on the wall closest. So from the point closest to the searchlight, so magkaroon tayo ng 15 meters dyan. Ito yun. Okay? So this is your beam at that moment. Okay? So same thing, we can put theta right here. So tangent pa rin, tangent theta. So the first thing we need to solve is the value of theta. Okay? That is equivalent to 15 over 20. And that is arctan of 15 over 20. That is about, okay, 36.87. 36.87 degree. Kanina kasi class, ito sabi dito that how fast the beam of the light moving along the shore the moment it passes the point on the shore nearest it passes. So yung mismong point natin na consider is at the point or the closest point nearest the beacon or the closest point to the beacon. So ito yun. Kaya automatic yung theta nito is 0 degree. Ito kasi meron distance. At the moment daw na 15 meters yung distance from the point closest to the searchlight. Kaya 15 dito. So we need to solve for the angle theta because obviously that is not 0. So ang nakuha na natin to, balik tayo sa tangent theta. In this one, in this case, yung 20 natin is constant. Hindi yan nag-change. Yung value ng x lang. Okay? So therefore, yung derivative nito is second squared theta d theta over dt, and that is equivalent to 1 over 20, okay? 1 over 20 dx over dt. Okay? Then, di ba yung second squared theta is equivalent to 1 over cosine squared theta, okay? D theta over dt equivalent to 120 dx over dt. Okay, from here, gagawin natin, let's isolate yung dx over dt because we need to solve for that. Okay? Therefore, we have here 1 over cosine squared theta d theta over dt times 20, and that is equals to dx over dt. So, unahin ko na lang si dx over dt. Dito na lang. Dx over dt. Okay? So, therefore, we have here dx over dt. That is equivalent to 1. Yung cosine squared theta, that is cosine yung nakuha natin ng angle, 36.87 degrees. So, yan, squared natin to. Okay? And then, d theta, that is 0.1 radians per second. Okay? And then, 20. If you will calculate this using your calculator, this is about 3.125 meters per second. Kasi ito meters na to eh. Meters na to. So that is rad times meter, that is meter. Kasi yung rad, unitless yan. And second will be uh, copy lang natin. Okay? So this is basically your answer for this problem. Now for our last problem, a rocket is launched vertically from a point on the ground 3,000 feet from a tracking station. When the rocket is at an altitude of 4,000 feet, it is traveling at a speed of 800 feet per second. How fast is the angle of elevation from the tracking station to the rocket changing at that moment? So, gawa tayo ng illustration. No? So, we have here our rocket station. So, basically, or tracking station. This is basically where we track the location of the rocket. So, if this is station, your station is said to be 3,000 feet from the launching pad. So, kung saan yung ila-launch natin yung rocket natin ito. So, this is 3,000 feet. Okay? And then, habang papunta yan sa itaas yung rocket, so, ito na yung rocket natin. So, at that moment na yung distance niya from the ground is 4,000 feet. And then, sabi dito, if we will say this is y, so yung dy dt daw is equivalent to what? Yung speed ng rocket traveling, no? Paitaas, so feet per second yan. So this is your dy dt. The question now is how fast is the angle of elevation? This one right here is changing at the moment that the rocket is in this position. So same thing, we can use the trigonometric function tangent. So tangent theta equivalent to y over 3,000. So before that, we need to solve for the tangent, the value of theta. So that is, at that moment na 4,000 feet yung elevation, and then yung 3,000, that is a constant value. So therefore, your angle theta is about 53 point. So ito yun na, arcta ng 4,000 over 3,000, and that is about 53.13 degrees. Okay, so therefore, balik tayo, tangent theta equivalent to y over 3,000. So if we will derive this one, this is about second square d theta over dt, and that is 1 over 3,000 dy over dt. Okay, so itong second theta, that is same thing with 1 over cosine squared theta d theta over dt equivalent to 1 over 3,000. And then we have here dy dt. So, isolate natin yung d theta over dt. So, from here, we have here d theta over dt. That is about 1 over 3,000 dy over dt. Then yung 1 over cosine magiging cosine. Okay, cosine squared. Okay, cosine theta square. Ayan, same thing yan, no? So, d theta, substitute natin yung mga values. 1 over 3,000. Then we have here 800 for dy over dt. Then we have cosine. Cosine ng 53.13 degrees, then squared. Therefore, d theta over dt is about 0.096. That is radians per second. Kasi ito, this is what? Feet, no? Ito naman, feet yan. Cancel yung feet. So, matira niyan is radians. This is 800 feet per second. So, that is radians per second. Unitless man itong radian. So, therefore, this is your answer for that problem. Okay? So, I hope nakuha nyo, no? Ang applications ng trigonometric functions, particularly ng time rates. So, we will still conduct our fifth examination on Monday. So, I hope that you will study. That is on March 30, if I'm not mistaken. No? So, don't be absent on March 30, 2026. So, we'll see you. Thank you, everyone, and have a nice weekend.